Welcome to my Ag-Aid Institute Summer Symposium 2023 presentation. My name is Aidan Wiggins, and my presentation is on visualizing data for grower decision making. A little bit about myself. I'm attending Whitman College, the class of 2024. I'm majoring in mathematics with a minor in computer science and religion. I'm originally from Maryland, but for school I'm residing in Walla Walla. This summer, I've been working at Innovate Ag through the Ag-Aid internship. Innovate is a Walla Walla, Washington ag-tech startup which empowers growers through the use of modern and relevant data. Innovate does so by processing and interpreting the data in-house. Innovate leverages multiple data sources, including the Green Atlas Cartographer, which provides in-orchard imagery, and also ambient in-orchard sensor data. There are a number of challenges that face growers in the new, modern context of data collection. On their own, growers struggle with constantly updating priorities and often have no time to take sensor datasets into full consideration. This is also exacerbated by the fact that nature is such a random force, and as such, constantly presses unexpected priorities upon the grower. And if a grower does subscribe to receive datasets, they often can be spread thin across applications and formats, with no hope or time for being able to decipher the data's meaning, and with no ease of figuring out what the data means. And with newer and newer technologies, it's also hard for growers to keep up with all the new ways they can receive data for their orchard. And oftentimes, growers are left with data which is non-localized and often a little off the mark of what is actually happening within their orchard specifically. Now we move on to the Grandview Smart Orchard. The Grandview Smart Orchard is a collaborative effort between Innovate Ag, the Washington Tree Fruit Research Commission, and WSU. It's set as a testbed for sensor technologies and research around these sensors. It currently has 2 to 3 years worth of data from multiple sources. This includes ambient sensor data, imagery from drones, satellite, and the Green Atlas Cartographer mentioned earlier, as well as soil texture and nutrient variability derived from gamma rays. To provide local and actionable data within the Smart Orchard, we have a couple different ambient sensors installed, each of which together yield millions of entries of data in our databases. In total, we have from different vendors a total of 10 sensors from Meter Group, which includes 5 atmospheric sensors, 2 leaf wetness sensors, and 3 soil water potential sensors. In the picture to the right, you can see an Atmos 41 sensor and one of the leaf wetness sensors. We also have floor pulse microtentiometer sensors installed seasonally, and Dynamax sensors, which include sap flow, digital irrigation meters, atmospheric sensors, and dendrometers. We chose to use Tableau, a commonly used data visualization tool, to visualize the ambient sensor data within the Smart Orchard. This dashboard iterates upon the work completed by previous Ag-Aid intern Mia Hargrave. The dashboard provides a view of one of Washington Fruit's Honeycrisp blocks, which is one of the more fragile yet profitable apple varieties. As such, sensor data is a crucial factor in aiding decision-making. This dashboard leverages data from both the Meter Group Atmos series of sensors, as well as the Green Atlas Cartographer data, which yields the orchard scan map seen here. This map shows us an estimate of the fruit counts within each plot, and we can thus see the effects of biennial bearing in the orchard year to year, where higher values will swap to lower values. Using the Meter Group Atmos series of sensors, we were able to use air temperature readings to give us the value for growing degree days, or GDD, in the orchard. GDD in general gives us an estimate of how heat-stressed an area is by accumulating heat units over time. Here we can see the difference between 2022 and 2023, with 2023 being a little hotter than last year. We can then use these values for growing degree days in the below coddling moth model, estimating when we should expect to need to manage for the moth. We also have some additional visualizations for air temperature in 2022 and 2023, as well as a distribution for the fruit counts seen here in the map. Reflecting back on the project, there were a couple of challenges that I personally needed to overcome to reach the dashboard view at all. I first most needed to learn to use and manage Microsoft Azure resources and the authentication therein. But the bulk of my time was spent working on the data pipeline for getting data via the API from each vendor into our SQL database, and then creating scripts to return calculated fields from that database for uses in our Tableau dashboard. A more recent addition is I needed to normalize the database in which we were storing the meter group sensor data. It previously had a handful of null values, which took up too much space. It now takes up about as much as a half as before. The Tableau dashboard also didn't explicitly support live feeds that were workable within our time frame, but I was able to update new sensor files to Google Drive and then have Tableau update from there, simulating a live view of the data. Finally, the data needed to be more actionable, and I was able to present our temperature readings in growing degree days to be more relevant to growers and future models thereby. Future steps might include adding more disease, pest, and growth models, simply waiting for more data so that we can get more historical context for a specific orchard. Also, integrating with weather forecasting to give more realistic GDD estimates and not just shooting in the dark. We can also incorporate more sensor technologies for a more diverse range of data to give a fuller picture of the view of the orchard. Also making the dashboard more actionable over time using the said previous models, but also mobile optimization and alerts. In conclusion, with climate change mattering more and more each year, it is important that growers have outlets of data they can access to best prepare for the effects of an ever-changing climate. Innovate is increasingly growing the infrastructure needed to support new sensor systems and means of appropriately storing this data. In addition, Innovate is also stepping in the right direction of being both the retriever and explainer of this data. And here are the credits for the slides, and thank you for attending my talk.